So welcome everybody to this latest video 162 Maths, and in this video we'll be going over another AQA GCSE Maths Foundation topic test around probability. Now as always there'll be a copy of the test paper for you to download by clicking on the link below if you wish to have a go at the paper before watching this video or while watching this video as we go through the answers. Now before we get started, it's worth mentioning that all of these questions are deemed to be non-calculated, so it's really important that you do show clear working out and also simplify your fractions where possible. So let's have a look at question 1. So question 1 says that the probability that a biased dice lands on a 3 is 0.25. The dice is rolled twice and it says complete the tree diagram. So for this, what we need to do is remember that these 3 and a not 3 are exclusive events. So the probability of those two events happening is either can or can't happen. So the probability of a 3 happening is going to be 1 minus probability of not 3 happening and vice versa. So to work out the probability of it not being 3, all I need to do is just take away 1 from 0.25, which is 0.75. And then if I just complete the tree by repeating those probabilities, that is what I get. So moving on to part 1b, it says work out probability that both of the rolls are not 3. So not 3 is going to be this probability times this probability. So it's going to be not 3 and not 3. So it's going to be 0.75 multiplied by 0.75. Now if you're good at multiplying your decimals, then that would be absolutely fine, in which you should end up with an answer of 0.5625. Now as this is a non-calculated paper, I would probably spot that that 0.75 is 3/4. And so if I'm then doing 3/4 times 3/4, that then becomes 9/16, or I can write the answer in as a fraction. So any of those two answers would be absolutely fine. And moving on to 1c, it says work out probability of scoring exactly 1/3. Well, there's two possibilities that can happen. Either I can get a not 3 and a 3, or I could get a 3 and not a 3. Now the probability of this happening is going to be 3/4 multiplied by 1/4. Plus, all means plus. So then I'm doing 1/4 multiplied by 3/4. And if I then simplify each bracket, so that's going to be 3/16 plus, and then work out the second. That's going to then give me 6/16, which simplifies to give me 3/8. And again, it's entirely up to you whether you write it as a fraction or you can write it as a decimal, and that as a decimal is 0.375 if you've opted for decimal multiplication and adding. But I would personally say working with fractions is definitely going to be the easier method. Moving on to question 2, it says the bag contains 20 balls. The ratio of red to blue balls is 3:7. A ball is picked at random and then replaced. So it basically means that a ball is picked and then put back. The bag is shaken and then a second ball is picked at random. Work out the probability that 2 red balls are picked. So let's have a look at this. So looking at the ratio then, if I know that there are 20 balls in total and they're either red or blue, and the ratio is 3:7. So if I do 20 divided by the total number of parts, which is 10, that equals 2. So that therefore means that I'm going to have 6 red balls and I'm going to have 14 blue balls. So then here, the probability of picking a red is going to be 6/20, and the probability of picking a blue, might be confusing as I'm writing in red, is going to be 14/20. And I can go on to simplify each of those probabilities respectively. It then says, going back to the question, it says work out the probability that 2 red balls are picked. Well, 2 red are going to be 3/10, the first one, multiplied and the second one being red. So it's going to be 3/10 times 3/10, which is going to be 9/100. So I can write that as 9/100. Or I could write it as a decimal as 0.09, depending on if you've opted for that route. Then part B then says work out probability that the balls picked are different colours. So if they are different colors, I'm looking for either a red and a blue, or I could end up with a blue and a red. So from this, the probability of picking a red is going to be, let's just go back to those numbers, 6 if I wasn't mistaken. So 6 out of 20, or 3/10. Let's work with the tenths. So it's got 3 over 10 multiplied by blue, which is 7 over 10. And then or means add, not times. Just put that in brackets. Plus, and then the blue was 7 over 10 times 3 over 10, which then becomes 21 over 100 plus 21 over 100, which equals 42 over 100, which simplified is 21 over 50. So I can write the answer as 21 over 50, or I could write it as a decimal using this as 0.42. So any of those two would be absolutely fine. Then says, how would the probability of a red for the second ball change if the first ball was not replaced? So for example, what that basically means is if the ball was not put back in the bag. So therefore, the probability of a second red, if a red had already been taken, would therefore be 5 over 19. And so there you go. So basically the probability of a red would change. Moving on to question 3, it says that a car passes through 2 sets of traffic lights each day. The driver records whether he has to stop at the lights over a long period of time and produces the following tree diagram. And the question says, tick the expression for the probability that the driver does not stop at the first set of lights. Well, with this, he either stops or he doesn't, so they are exclusive events. So the probability of this happening and this has got to be equal to 1. So therefore, the probability of him not stopping is going to be 1 minus the probability of him stopping, which in this case is x. So it's going to be 1 minus x. So I need to tick that box there. Then moving on to question B, it says that work out the expression for the probability that the driver does not stop at the first set of lights and but does stop at the second set of lights. So let's first of all complete this diagram. So here, if this is y, this is going to be 1 minus y, and this is going to be y, and that's going to be 1 minus y. So going back to the situation, it says that the driver does not stop at the first set of lights. So does not stop is going to be 1 minus x. Do not stop at the first. So that's going to be 1 minus x. And then does stop at the second, which is going to be y. So and means times, and doesn't stop, well, that's just the probability of y. So then writing this as an expression, we multiply those two things together. So it's going to be y multiplied by 1 minus x in brackets, or you could write your answer as y minus xy. Any of those two would be fine to get the mark. It then says work out the expression for the probability that the driver stops at least one set of lights. So here what we could have at least one, so we could either stops and not stops, or we could have not stops and not stops. Well, actually that's not going to work. Either stops and not stop is the same. So let me just go back and change that. So you can either not stop at the first set but stops on the second, or you can stop at twice. So then let's have a look at each of these as expressions. So stops and not stops. Again, if we go back to our diagram, so stops and then not stops is going to be x and then 1 minus y. That's x, 1 minus y. Or means add, so we're going to add. And then if we work out with this one here, doesn't stop, well, that's going to be 1 minus x, and does stop, which is y. And then we move on to our next one. So again, plus, and then stops at both lights. Well, stops at both lights is going to be xy. And that there is going to be this. So then what we then need to do is then simplify this expression. So if I expand this out, I get x minus xy. plus, expand this out, I get y minus xy, and then I've got plus xy. So then collecting all of the like terms, let's have a look at what cancels out. Well, this will cancel out with this. So then what is left? Well, I'm left with a positive x, I'm left with a positive y, and I'm taking away one set of x minus y. So that there is my final answer.